When you download this paper from the VCAR site, it has, where the picture was in this question, it has, due to copyright restriction, this material has not been supplied. But it's just a picture, I'll put one up here, of this interference pattern formed by either X-rays or electrons going through a crystal. The same sort of picture they have every single year, basically. Anyway, oh no, this is X-rays. Yes, they are X-rays, and here they've got the energy of 80 kilo electron volts. So 80,000 electron volts. A thin metal foil, and then you get a diffraction pattern, which is similar to this one. Alright, magnitude of the momentum of a single X-ray. So in our formula sheet, we've clearly got a photon column and an electron column with all our formulas in. And one that goes into both of them is P equals H over lambda, one of the only ones that goes into both of them. Alright, so that's what we want, P equals H over lambda. First thing I have to do here would be to, this is my energy of my photon, and I'd have to say energy equals Hc on lambda, and then rearrange and I get lambda equals Hc on E, and then once I've done that I can say P equals H on lambda. There's actually a faster way to do it. There's another formula in my photon table that says E equals Pc. And I'm going to use that one because it has straight energy and it has momentum in the same thing. It's effectively these two formulas put together. Alright, here we go. So I've got E equals Pc. We've got our energy. This gives energy in joules. So I've got to say my energy equals 80,000 electron volts, which when I times it by 1.6 by 10 to the minus 19, I get 1.28 by 10 to the minus 14 joules. Okay, so my energy is now in joules. I can now use the formula. E equals Pc, P equals E on C, which equals 1.28 by 10 to the minus 14 divided by C, same as always, 3 by 10 to the 8, which gives me 4.26 by 10 to the minus 23. Now, I could have gone ahead and done it this way, but this way is just a little bit faster. And because I've practiced enough, I know I can just jump straight into it. The only hard thing here was making sure the 80,000 electron volts was into joules. Right, students are aware that electrons can also be used to form diffraction patterns like the X-rays above. They wish to use a beam of electrons. Student A says that the fringe spacing will be identical if the electrons have the same momentum. That's what student A is saying. And student B is saying that the fringe spacing will be identical if the electrons have the same energy as the X-rays. Which student is correct? Right, I'm just going to go, I don't know which student's correct. I'm going to work through my answer and hopefully get to which student's correct. What I do know is for the patterns to be the same, the X-rays and electrons have to have same wavelength. Alright, because P equals H on lambda for both electron and X-ray, they will therefore have the same momentum. And in that case, same momentum, student A is correct. is correct.